While NASA sits on the highest resolution images ever taken of an interstellar object, China just released theirs to the world. And what they show is raising more questions than answers. Because 3I Atlas is now glowing green, the debris cloud is still missing. And a Harvard astrophysicist just issued a warning about unwanted gifts for the holidays. This is the biggest 3I Atlas update yet. Multiple breaking developments in the last 48 hours, and what happens next could determine whether this is the most unusual natural comet in history, or something that changes everything we thought we knew about what's possible. Good morning. In the past 2 days, we've had 4 major developments. First, China released close-up images from their Mars orbiter while NASA's better images remain locked away due to the government shutdown. Second, new observations show 3I Atlas glowing green, its third color change since discovery. Third, the missing tail mystery deepens with fresh data confirming the debris cloud still isn't visible. And fourth, Loeb published a message about the object potentially delivering unwanted surprises as it approaches Earth in December. Before we dive in, if you want to stay on top of this rapidly developing story, hit subscribe and turn on notifications. This is moving fast, and tomorrow there could be major announcements. Your subscription genuinely helps us continue this coverage. Now let's break down what just happened. November 6, 2025. The China National Space Administration drops a bombshell. They release images of 3I Atlas captured by their Tianwen-1 Mars orbiter on October 3rd, when the comet passed just 28.96 million kilometers from the red planet. Clear images, publicly available, free for any scientist in the world to analyze. Here's what makes this extraordinary. NASA's Mars Reconnaissance Orbiter also photographed 3I Atlas on October 3rd using its HiRISE camera. And those images are better, much better. HiRISE has a 50-centimeter aperture compared to Tianwen-1's 38 centimeters. According to Loeb, the NASA images offer about 3 times the resolution of Hubble Space Telescope's July observations. They're the highest resolution images of an interstellar object ever captured, but you can't see them. Because on October 1st, the United States government shut down, and NASA's data release policy during a shutdown is clear: no new public releases. The images exist. Scientists have seen them, but the public, the international research community, anyone who wants to analyze this historic interstellar visitor, they're locked out. Representative Anna Paulina Luna from Florida has been pushing NASA hard on this. On October 31st, she sent an official letter to NASA's acting administrator demanding immediate release of the data. On November 5th, she tweeted, "Just had a good conversation with NASA regarding 3I Atlas. As soon as the government reopens, they'll be releasing images, data. Unfortunately, due to bureaucratic reasons, they cannot until then." Think about that for a moment. We have unprecedented images of only the third interstellar object ever observed. Images that could help answer fundamental questions about cometary behavior, about how these objects survive billions of years in interstellar space, about whether the anomalies we're seeing are natural or something else. And they're sitting on a government server, inaccessible, because of budget politics in Washington. Meanwhile, China moves forward. The CNSA explained that photographing 3I Atlas was incredibly difficult. The object is 10,000 to 100,000 times dimmer than the Martian surface that Tianwen-1's cameras were designed to observe. It's moving at 58 kilometers per second relative to the spacecraft. The team had to run extensive simulations, develop new imaging strategies, adjust the orbiter's attitude control systems, all to capture a target their spacecraft was never designed to photograph. And they succeeded. The images show 3I Atlas's nucleus surrounded by a coma several thousand kilometers in diameter. You can see the fuzzy, glowing atmosphere of gas and dust. The comet's features are clearly visible. It's not high resolution by HiRISE standards, but it's data, real data, available data. If you're finding this as fascinating as I am, please take a second to like this video. It helps the algorithm show this content to more people interested in these developments. This isn't just about image quality. It's about scientific transparency and international cooperation. Loeb put it perfectly in his latest blog post. He literally had to acknowledge China for releasing their data while still waiting for NASA's superior images. In 2025, in the age of supposed scientific openness, we have a situation where geopolitical factors are determining who gets to see unprecedented astronomical data first. The irony is thick. The United States has better technology, better instruments, better resolution. But China has faster bureaucracy and no government shutdown. So the world sees China's images of this historic object, while NASA's remain classified by circumstance rather than choice. Now let's talk about what's happening to the comet right now, because something strange is going on. November 6, 2025, Chichengjiang at Lowell Observatory uses the Discovery Telescope to capture fresh observations of 3I Atlas as it emerges from behind the Sun, and the comet is glowing green, not blue, not the reddish color it showed in earlier observations. Green. A distinct green glow emanating from the coma. This is the third time 3I Atlas has changed color since discovery. In July and August, observations suggested a slightly reddish hue. Then near perihelion in late October, it turned blue, bluer than the Sun itself according to observations from solar monitoring spacecraft. And now, post-perihelion, it's green. For those wondering what causes green comets, it's typically dicarbon molecules, C2. When these molecules are excited by solar radiation, they emit light at specific green wavelengths. It's not uncommon for comets to show a green tint. Comet Neowise in 2020 had a beautiful green coma. Comet Lovejoy in 2015 was spectacularly green. But here's what makes 3 Atlas's green glow interesting. Most comets show a consistent color profile based on their composition. They don't cycle through multiple distinct colors over the course of a few months. The color changes suggest either variable composition in different parts of the nucleus being exposed as it rotates and outgasses, or changing solar heating patterns creating different chemical reactions at different distances from the Sun. The green glow itself isn't anomalous. What's unusual is the pattern, red to blue to green, with each color shift corresponding to different phases of the comet's journey. It suggests a complex heterogeneous composition. Different ices, different minerals, different layers being exposed and activated as the comet heats up and cools down during its perihelion passage. Live Science describes the new image showing the comet hiding its tail while glowing green. That phrasing is deliberate. The green glow is visible. The nucleus is clearly active, releasing gas and creating a coma, but the expected massive cometary tail, still not prominently visible, which brings us to the ongoing mystery that's now officially frustrating multiple independent research teams. The November 6th Lowell Observatory image, the same one showing the green glow, also confirms what earlier observations suggested. There's no massive debris cloud, no spectacular cometary tail streaming away from the Sun. Just a compact, fuzzy coma around a bright nucleus. We covered this extensively in our previous video about the November 5th observations from Arnave's observatory and the Virtual Telescope project. But it's worth repeating because new data keeps reinforcing the same impossible-sounding conclusion. NASA confirmed non-gravitational acceleration. The measurements are robust, standing at 3.7 standard deviation detection. That acceleration requires outgassing. And outgassing at the level needed to explain the acceleration means massive mass loss. Loeb calculated at least 13 to 15% of the comet's total mass. For an object several kilometers wide, that's billions of tons of gas and dust. When that much material escapes, you get a debris cloud. You get a tail. It's basic physics. Solar radiation pressure pushes the dust away from the Sun. The solar wind sweeps up the ionized gas. These forces create the classic cometary tail structure visible from millions of kilometers away. Comet Lemon, photographed by the same observatory that captured 3I Atlas just days apart, shows a perfect example. Clear, bright tail streaming away from the Sun exactly as physics predicts. Normal comet behavior, 3I Atlas, compact fuzzy ball, active nucleus, green glow confirming gas release. but no massive tail structure matching the calculated mass loss. Multiple explanations have been proposed. Maybe the dust particles are unusually small, scattering light in ways that make the tail nearly invisible from certain viewing angles. Maybe the dust-to-gas ratio is extreme, with mostly gas escaping and very little dust to reflect sunlight. Maybe the composition is so unique that standard cometary physics models don't apply. Or maybe, as Loeb continues to point out, the non-gravitational acceleration isn't coming from outgassing at all. Maybe it's coming from something else. He doesn't claim it's artificial. He's asking, given the accumulation of anomalies, shouldn't we investigate all possibilities rather than assume we know the answer? The scientific debate continues. Most astronomers lean toward a natural explanation involving unusual but possible cometary behavior. A minority, led by Loeb, argue that the statistical accumulation of improbabilities demands we keep alternative hypotheses on the table until definitive evidence rules them out. And that brings us to Loeb's latest message published yesterday. It's titled, "The Inspiration Delivered by 3i Atlas to Our Doorstep," and it contains a line that's generating significant discussion. He writes, "My hope is that data collected in the coming weeks, especially around December 19th, 2025, when 3i Atlas gets closest to Earth, will reveal the true nature of this interstellar object. Let's hope that 3i Atlas will not deliver us unwanted gifts for the holidays." Unwanted gifts for the holidays. What does that mean? December 19th is 6 days before Christmas. It's when 3i Atlas makes its closest approach to Earth at 168 million miles. That's a safe distance, 1.8 times farther than the Sun. NASA has confirmed repeatedly that the object poses no impact threat, but Loeb's concern isn't about physical collision. It's about trajectory changes, potential signal emissions, or the possibility of deployed objects. In his previous writings, he's speculated that if 3i Atlas were an artificial probe, it might release smaller sub-probes as it approaches planetary targets. December 19th would be the optimal time for such a deployment if Earth were the target. Is this likely? Most scientists would say no. Is it scientifically responsible to monitor for such possibilities? Loeb argues yes. If you have an object with 10 documented anomalies, approaching Earth during a period when hundreds of telescopes will be watching, you collect every piece of data possible. You look for any unexpected activity. You remain open to what the evidence shows rather than what you expect to see. The message also reveals something else interesting. Public engagement with this story is massive. Loeb shares that he's receiving hundreds of emails from around the world, people expressing fascination, parents saying their kids are asking about 3i Atlas updates every day after school, children requesting telescopes for Christmas so they can observe the comet themselves. One message from Mexico reads,
"Every day my son asks about the latest news from 3i Atlas. He told us he would love a telescope for Christmas.
Thank you for being such an inspiration and making us love science and astronomy. This matters, because regardless of whether 3i Atlas is the strangest natural comet ever observed or something more unusual, it's inspiring a generation to look up, to ask questions, to want to be part of the discovery process. That's the real gift, whatever happens on December 19th. So where do we stand? Let's summarize the current situation. China has released images showing a clear cometary coma around 3i Atlas, confirming its active nature but also showing the compact structure without an obvious massive tail. NASA's higher resolution images remain unreleased pending the end of the government shutdown, though Representative Luna confirms they will be made public once that happens. New observations show the comet glowing green, its third color change indicating complex composition and active outgassing. The missing tail mystery persists, with no clear debris cloud visible despite calculations requiring massive mass loss. And December 19th looms as the critical observation date when the comet makes its closest approach to Earth. Between now and then, we have several key milestones. November 11th, just 4 days away, marks when amateur astronomers with 8-inch telescopes can start observing 3i Atlas in the pre-dawn sky. The comet will be in Virgo near the bright star, Spica at magnitude 10 to 11. Thousands of amateur observers worldwide will be looking for one thing: evidence of the missing debris cloud. November 17th. The Virtual Telescope Project hosts a live observation event, real-time imaging of the comet, streamed publicly, allowing anyone to see exactly what professional telescopes are capturing. This is citizen science at its best. November 27th. The International Asteroid Warning Network begins a special observation campaign running through January 27, 2026. Remember, how normally focuses on potentially hazardous asteroids. Their involvement with a comet, especially one confirmed to pose no Earth impact threat, is unusual. It suggests heightened scientific interest or training opportunities with a unique target. December brings the heavy hitters. The James Webb Space Telescope makes its second round of observations, performing detailed spectroscopic analysis of the comet's composition. If there's anything chemically unusual about the molecules being released, Webb will detect it. The Hubble Space Telescope will conduct ultraviolet spectroscopy to determine gas composition and ratios. And December 19th, closest approach. Hundreds of ground-based telescopes, multiple space observatories, coordinated international observations. This is humanity's best chance to gather definitive data on 3I Atlas. The debris cloud question will be settled. The composition will be analyzed. Any anomalous behavior will be documented. After that, ESA's JUICE spacecraft data arrives in February 2026. JUICE observed the comet on November 4th from 40 million miles away using multiple instruments. That data could confirm or refute several of the reported anomalies. March the 16th, 2026, close approach to Jupiter. NASA's Juno spacecraft will observe the comet and potentially use its radio antenna to search for electromagnetic emissions. If 3I Atlas is transmitting anything, intentionally or through natural processes, Juno would be positioned to detect it. What makes this story compelling isn't speculation about what 3I Atlas might be. It's watching multiple layers of complexity unfold simultaneously. You have the scientific mystery. 10 documented anomalies, each individually unusual, together creating a statistical profile never seen before. Missing debris despite confirmed acceleration. Multiple color changes. Perfect timing for unobserved perihelion passage. Industrial nickel signatures. Wow signal directional alignment. The accumulation demands explanation, whether natural or otherwise. You have the geopolitical dimension. The United States possesses better data but can't release it due to internal dysfunction. China releases their data first, gaining soft power and demonstrating efficient decision-making. The irony of superior American technology being rendered irrelevant by bureaucratic paralysis. You have the public engagement aspect. Millions of people following this story. Children inspired to study astronomy. Amateur observers preparing to contribute real scientific data. A global community united in curiosity about a visitor from another star system. And you have the December 19th deadline, a specific date when everything comes together, when the comet is closest, when the observations are optimal, when the questions might finally get answers. Whether 3I Atlas is the most unusual natural comet in recorded history, or something that challenges our assumptions about what's possible in the universe. We're privileged to witness this moment. An object that traveled for billions of years through the void between stars, arriving in our solar system when we have the technology to study it, the coordination to observe it globally, and the curiosity to wonder what secrets it carries. December 19th, 2025. Mark your calendars, because that's when we'll know. If you want to be part of this discovery, if you have access to an 8-inch or larger telescope, you can observe 3I Atlas yourself starting November 11th. Look for it in the constellation Virgo before dawn, near the bright star Spica, magnitude 10-11, so dark skies will help. Report your observations to the Minor Planet Center. Your data will contribute to the professional analysis. If you don't have a telescope, watch the Virtual Telescope Project's live event on November 17th. See the comet in real time. Participate in the chat. Ask questions, be part of the community solving this mystery, and subscribe to this channel for updates as they happen. When NASA releases the high-rise images, we'll cover it. When December 19th observations come in, we'll analyze them. When the final data from all sources is compiled, we'll explain what it means. To everyone watching, thank you for engaging with science even when it's uncertain and complicated. Thank you for being curious about an object from another star system passing through our cosmic neighborhood. Thank you for demanding transparency, supporting research, and keeping that sense of wonder alive. Because whether this is the strangest comet ever observed, or something that rewrites astronomy, we're watching history unfold together. China's images are available now. NASA's will come soon. The green glow is documented. The missing tail remains unexplained. And December 19th approaches. Keep watching the skies. Keep asking questions. And let's see what 3i Atlas reveals when it passes closest to Earth in 42 days.